Hello, this is Angela from Neurocraft, and today I want to show you how I managed to update the old environment to make two agents playing against each other. So as you can see, contrary to the first implementation that I did, that we had just a single pad against the wall, here you can see two agents playing Pong against each other. So as you can notice, the speed of the ball increases by a little bit when they deflect. So it starts with normal speed, but each time one agent deflects the ball, it increases the speed by 20%. And you can see the agents are doing very well against each other. So I want to see how I managed to implement it in C++. I will discuss some minor details here, but as you can see, it learns very well to play against each other, despite the fact that they are not trying to beat one against the other, because when one agent receives its state or observation, they don't know if the other paddle lets the ball pass or not. So there is no communication protocol between them. But as you can see, they do very well against each other. Okay, so let's give a little overview how I managed to do that. So first, what I did here, I want to share the AI versus AI implementation that I did using deep reinforcement learning. So I used the Pong of chapter 1 of this incredible game programming book from Sanjay Madhav. So while he implements just a single pad against the wall using a human interface, so you control the ball, here I added two paddles for the same game. I added a 20% speed increase when deflecting the ball, and I did the environment step decouple from the game step, meaning that we can trade the agent without needing to render the game. So this speed allows the training process. Okay, the next step is about the environment, how I coded it. So starting by the reward, every time a paddle deflects the ball, it receives a reward of +1. And every time a paddle lets the ball pass, it receives a negative reward or a penalty of -10. Okay, and each episode ends after one side score 21 balls, against each other. So if player 1, for example, lets the ball pass 21 times, the game ends. A single state is composed by 8 variables: ball position in XY, paddle position XY, ball velocity and paddle velocity as well. And a single observation is composed of 2 stacks with 3 states containing 24 variables. So I collect the single state in 3 frame steps. Then I concatenate them and let a single observations for each agent. And also each agent receives its own observation of the current state. So while player 1 receives the paddle position from itself, the player 2 also receives the paddle position of itself, not the paddle position of the other player. So this is why we can tell that there is no communication protocol, and we don't know beforehand how each other player interact with the environment, meaning that we are trying to cheat as little as possible. Okay, now about a little bit about the agent. I did a single agent using the DQN implementation containing 2 neural networks, one for policy or policy pi, that receiving a state, it predicts the the agent action and a target of offline policy, so we can more or less convert this reinforcement learning in supervised learning. Okay, I also implement a replay buffer that we store the experience, that tuple experience of current state, action, reward, next state, and done. Also, the parameters for the training process, I used a learning rate of 0.0005, a gamma discount reward of 0.95, a memory size of 10,000, experience, a batch size of 64, and we update every neural network after 20 steps. Also, the neural network implementation over here, you can see that we have 4 fully connected layers. I mean, we can call that 3 instead of 4. So with an input of 24 variables containing the state space, as you can see over here, a stack of 3 frames containing the ball position, pedal position, ball velocity, and pedal velocity. Then we have another layer, hiding layer, containing 128 neurons and a ReLU activation, another 128 hiding layers containing again ReLU activation, and the output layer containing no activation but just 3 neurons corresponding to the action space that could be none. Our pedal could be just stand still, up, or going down. Okay. Then here is the training process. Just explaining a little bit, I decoupled the exploration versus exploitation paradigm between the environment and the agent. So I didn't hard code this process inside the agent that normally you see on the implementations of Python, over the internet. So I started with epsilon of 1 and decay after every episode of 0.01 with a minimum exploration of 0.1, okay? And the training process, I let 10,000 steps. So here you can see on the right the score increasing after the number of episodes, so I get just the maximum score between both players. So we can see over here in the last step that after 1063 episodes, the one player get a maximum score of 447 reward. Okay, remember that he receives a reward of 1 every time he deflects the ball and -10 after he let the ball pass. And now the just final consideration for the next steps, that is move past chapter 1, enough of just Pong game, update high-level neural network to accommodate different layers of convolution, concatenate, because to implement another types of deep reinforcement learning like DDPG and actor critic methods, we need to have those layers. Okay, so back to our game. If as you can see over here, just to give some minor details about the code now. Okay, just I implemented the training process and the playing process on the main.cpp. The agent, the DQ agent, I implemented on the agent file. You can also accommodate another agent as well, so you can use this space over here to implement your own agent player. Then we have a replay buffer, okay, that we can store the experience of a current state, current action, reward, next state, and done. Then our agents, like I said, you pass some state space and action space. So the policy and target network are built using those initial and the layers, but the hidden layers you can pass with a configuration file. So here you have this struct called DNA agent config that you can pass the learning rate, gamma, hidden fully connected neurons, hiding true, and so on, the memory size and the other parameters, because as you can see, C++ is not very friendly, parameter friendly when creating a class. Okay, so I think we did some good progress on the current agent over here. As you can see, they learned to play Pong very well, you know, after a lot of practice, and you have a lot of parameter tuning. Also, I added this, you know, a little challenge that I create some speed, you know, to make the agents more have to learn a little more how to predict the where they have to be on the screen while playing against each other. But as you can see, the deep reinforcement learning worked very well here, despite the fact that they are not playing against each other, but they are more trying to survive, you know, not letting the ball pass. But could be really good to have a future implementation where you establish a communication protocol where you can inform one player that the other lose the game, so you can try to make them or play more cooperative friendly or really against each other. Okay, so that's it for today. Thanks for watching, and until next time.